Welcome back to The Explainer. Today, we are diving into something absolutely wild. We're going to explore how the literal, microscopic, physical architecture of computer chips actually dictates the multi-million-dollar strategies of modern venture capital. I know, it sounds totally crazy at first glance, right? Like, what does the microscopic silicon in your laptop have to do with high-stakes finance? Well, today, we're going to unmask this massive hidden link between the two and really get into the startling reality of digital trust. Let's jump right in.
Here's our roadmap for the journey today. We're going to hit 1. Capital must be exact. 2. The FPU gambler problem. 3. The wood chipper effect. 4. The exact ALU surveyor. 5. Capital as a ledger. And finally, 6. Superlinear capital growth.
All right, part 1, capital must be exact and the illusion of digital trust. So, we all interact with incredibly advanced AI systems every single day. And it's super easy to just assume that, underneath the hood, these machines are executing perfectly exact, mathematically sound logic. But we really need to challenge that assumption right out of the gate. In high-liability environments, whether you're managing enterprise finances, executing smart contracts, or running critical infrastructure, you need absolute truth. You just can't build a trusted ecosystem on an illusion. And this is exactly where a concept called Providence VC comes in. Top-tier venture capitalists focused on this philosophy aren't just placing random bets, they're architecting the infrastructure of the future. But to actually pull off this Providence VC model, they can't just rely on good vibes or strong narratives. They absolutely must have a mathematically perfect, undeniable ledger of who owns what. They need perfect provenance, a totally unbreakable chain of title. But as we're about to see, the physical computers running our global economy actually make this level of perfect trust mathematically impossible.
Which brings us to part 2, the FPU gambler problem, or what we can call blurry peripheral vision.
Let's zoom all the way down to the microscopic level to meet the real antagonist of our explainer, the actual physical hardware component that's making true digital trust impossible. Get this, 80 to 90% of modern AI compute cycles are actually just hardware-level approximations. They aren't exact math at all. When massive language models do their heavy lifting, the physical engine driving them isn't calculating absolute ground truth reality. It's fundamentally an estimation system, making highly educated guesses just so it can process massive amounts of continuous data incredibly quickly.
To really understand why this happens, we have to draw a hard line between two very different parts of a computer's physical brain. On one side, we have the floating point unit, or what we're going to call the FPU gambler. It acts a lot like your peripheral vision. Super fast, highly parallel, but fundamentally blurry and lossy. It's totally probabilistic. On the exact opposite side, we have the arithmetic logic unit, the ALU surveyor. This is your forensic focus. It's deterministic, exact, and deals only in undeniable truths. The massive problem we're facing right now is that modern AI relies almost entirely on the wildly guessing gambler.
And here is the crucial point about how the gambler actually makes these guesses. When the FPU encounters heavy, complex math, it essentially throws darts at a board to approximate the answer. And to do this fast, chip manufacturers literally burn their own proprietary, completely secret mathematical seed tables directly into the physical silicon. This means your computer's approximation of a complex equation might actually be fractionally different than my computer's. It causes what experts call non-deterministic drift. Because the underlying math is quite literally a corporate trade secret, getting exact one-to-one mathematical reproducibility across different machines is physically impossible.
So, moving on to part 3, the wood chipper effect and massive data destruction.
Now, you might be thinking, a microscopic rounding difference probably doesn't matter if you're just browsing the web, right? And you'd be right. But the consequences of relying on this FPU gambler for high-stakes digital work are catastrophic. Let's walk through how this data destruction actually goes down. Step 1. The AI ingests exact source data. Think copyrighted books, sensitive financial ledgers, or a human artist portfolio. Step 2. The non-deterministic FPU hardware approximates the math using those secret silicon tables we just talked about. And Step 3. Because that math was just a guess and not a precise trackable calculation, the exact path of that data is permanently destroyed. The original provenance and chain of title are gone forever.
Just let that sink in for a second. The source material has this brilliant metaphor for this. The FPU basically acts like a giant blender. You know exactly what went into the blender, but you absolutely cannot reverse engineer that smoothie back into the exact fruits it came from. Once that math is guessed, it is a strict one-way street. The chain of title is totally irreversible.
This creates an absolute nightmare for digital trust. It leads to what researchers call the liquidation of contributors. When the machine grinds up human effort using approximations, it wipes out the identity of the original creators entirely.
Without an exact deterministic mathematical path, you just cannot prove provenance. It creates unmanageable legal liability and makes high-stakes financial and legal sovereignty practically impossible. You absolutely cannot build verifiable trust on a foundation of guesswork.
Okay, let's hit part 4, the exact ALU surveyor, our deterministic antidote.
The hero of our explainer, the actual antidote to this massive hardware flaw, has been sitting inside our computers this entire time. Remember our surveyor, the arithmetic logic unit? Unlike the gambler, the ALU deals strictly in absolute, 100% verifiable hardware truths. In the ALU, 1 + 1 equals exactly 2, every single time, with absolutely no hidden seed tables involved. It operates the exact same way on literally every single CPU on Earth.
By intentionally shifting our core math away from the FPU gambler and handing it over to the exact ALU, we completely change the game. We can use rigid, structured text as a sort of semiotic bridge to communicate our exact intent to the machine. By bypassing those sloppy approximations, we leave an undeniable, exact digital receipt. This restores what physicists call Noether's theorem of reversibility, which basically means we can literally work backward forensically. Every single decision traces back to a highly auditable, mathematically absolute path.
Let's zoom back out for part 5, capital as a ledger, and the modality mismatch.
Now that we really understand the stark difference between exact hardware determinism and blurry hardware guessing, how does this all connect directly back to the very definition of capital itself? Well, here's the core philosophy of our explainer today. Capital, at its most fundamental level, is a ledger. True digital capital requires an absolute, mathematically deterministic, and undeniable record of provenance. If you can't definitively prove who owns what, the whole ecosystem crumbles under audits and lawsuits.
So the aha moment here is massive. Because true capital requires an exact ledger, a guessing machine simply cannot function as capital. The FPU gambler is fundamentally unfit for financial sovereignty. Only the deterministic, exact, verifiable logic of the ALU surveyor can actually function as literally intelligent capital, serving as a globally accountable universal witness.
Which brings us to our final section, part 6, superlinear capital growth and the ultimate economic payoff.
So what actually happens when we make this hardware shift and bake undeniable trust right into the silicon? Right now, companies operate under a massive burden called the mask-rendering cost of narrative trust. Think of this as a huge hidden tax. Because their underlying hardware is essentially guessing, companies are burning millions of dollars on endless legal fees, third-party audits, and months of wasted time just trying to prove who actually owns a piece of intellectual property or a digital asset.
But when you establish perfect provenance hygiene by using the ALU, you're literally baking the chain of title directly into the digital substrate itself. You don't need lawyers to argue a narrative anymore. The system is undeniably true. When trust is backed by exact physical silicon, that metabolic cost of doing business absolutely plummets. The cost of trust drops to near zero, all because the math itself undeniably proves the chain of title.
And this right here creates the superlinear effect. In this new paradigm, trust just becomes a frictionless feature of the hardware. The massive capital saved from skipping all those grueling audits and legal battles doesn't just disappear. It feeds directly back into the mathematical exponent of the system. This allows visionary venture capital to achieve true superlinear, exponential growth. It unlocks an era of extreme legal abundance, where contracts execute perfectly and the verification overhead is completely gone.
We are hurtling toward a future where our digital systems will manage trillions of dollars, complex legal contracts, and our most critical infrastructure. So I want to leave you with a final, provocative thought to really ponder today. As we offload more of our lives onto machines, what standard of accountability are you willing to accept? Are you going to settle for a gambler's fast, destructive guess, or will you demand the surveyor's exact, undeniable truth? Honestly, the entire future of how we trust artificial intelligence depends entirely on how we answer that question. Thanks so much for joining me on this explainer today. Keep questioning your systems, and until next time, keep learning.